Hey, what's up everyone? This is MusicTechHelpGuy, and in this video, I'm going to show you how to match dialogue, voiceover, and narration tracks that maybe were done with different microphones or in different acoustic environments, or maybe the proximity is different. Maybe in one recording, the speaker is a bit further from the mic, another recording, the speaker is a bit closer to the mic. And I find myself doing this actually quite often with my YouTube videos because if I do like a DAW demonstration, like something in Logic or anything that's software related, I'm just speaking into my main voiceover mic, which is my Earthworks icon. And then sometimes I'll turn around and I'll have the desk sort of be my backdrop, and I'll be presenting something or talking about something there, and I may use a different mic for that, or I may have the mic a bit further away from me, or maybe you're trying to match a full-size mic to a lapel or lavalier mic, or maybe you're trying to match boom mics, picking up dialogue on set for like movie and film production. So there's a lot of applications for this, and it's actually quite easy to do in Logic because Logic has a stock match EQ plugin. So for this example, I've read a couple of paragraphs from a MIDI textbook. So this very first part here in blue, this was all recorded with the Earthworks icon, which you're also hearing on my voice right now, but this is completely dry. There's no effects on it. And then this recording down here is done on a Blue Yeti USB mic. And it's got a little hotter pickup. It's got a bit more top end, whereas the Earthworks is a bit warmer. And I'm actually a bit closer to the Earthworks in my reading. And I'm going to match these two dialogue parts so that they can play back to back seamlessly without hearing a really noticeable change in the audio. Now, the way the match EQ works is you can learn a reference EQ curve, and then it compares that reference EQ curve to a current EQ curve, and then creates a custom EQ curve to try to make the current audio sound more like the reference. So the way this works is you're going to want to load the match EQ first on whatever the reference is. What do you want the audio to sound like? That's the reference. But there's really a step you have to do before you even use the match EQ, and that is to match the gain of the two recordings, because in this situation, the Earthworks is going through like a real mic preamp and going into my Symphony IO, whereas the Blue Yeti is just plugged in over USB. It is its own audio interface, and so the gain is a little bit different. And you can see that this is a bit softer and this is a bit louder. So let's listen to like the tail end of this moving into the beginning of this. Understanding what MIDI is all about. Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language. Okay, so this is definitely too loud and this is too soft. I'm going to try pulling this down by like 3 dB. So I'm just going to select all of those regions, and over in the inspector, I'll just type in 3 dB to reduce the gain on those. You could also use the gain tool as well. And then for this one, I think I'm going to add 6 dB of gain. And because the EQ curve for both of these mics is different, there's still going to be a bit of a noticeable difference in volume. Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language, and a list of specifications. Yeah, so you can really tell the difference between this mic and that mic. So what I'm going to do first is I'm going to select all of this and hit Command U to put it in the cycle range. I'm going to pull up the match EQ track on the reference audio. I'm going to click reference here, and then I'm going to click learn, and I'm going to play back a bit of this audio. MIDI is a standard, a protocol, a language, and a list of specifications. It identifies not only how information is transmitted, but also what transmits this information. Just like AC/DC current identifies the type of electrical current, it also identifies how cables are connected and what type of cables should be used to transmit this current. Okay, then I can uncheck learn. It's learned an EQ profile for this audio. Now what I'm going to do is I'm going to move the match EQ over to the Earthworks track, and we're going to try to make the Earthworks mic sound a little more or pretty close to the reference audio. So what we're going to do is go to current, click learn again, and we're going to play back a good portion of this recording.
MIDI is an acronym for Musical Instrument Digital Interface. It is a communication standard that allows musical instruments and computers to talk to each other using a common language. At this point, you might be thinking, well, I knew that. If so, great. If not, you have just taken your first step toward understanding what MIDI is all about.
Okay, so once you've learned your current and reference, you can go over to EQ curve and select match. And what this will do is it'll create a custom EQ curve to match this audio to be more like this audio. Now, a couple controls you want to play around with here are the smoothing and the apply. This is just like how much of the effect are you going to hear. I rarely use this at 100%, but let's put it up at 100%. And the smoothing will sort of just round out all of the details in the EQ curve to make the changes kind of more broad. But honestly, I like it with less smoothing because I like all these little nooks and crannies in here. They really match the detail of one mic to another. So let's play this. I'm going to play it from like here to here, and let's hear how well these two mics are matched just with the stock setting.
Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language, and a list of specifications.
Okay, so this is kind of thin. Let's pull back the apply to like maybe 50%.
Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language, and a list of specifications.
So the top end and the mid-range is getting pretty close. The bottom end in this mic, it definitely needs more bottom end. So I think what we're going to do is we're going to add the channel EQ to this mic, and we're just going to beef up the bottom end a little bit.
I knew that. If so, great. If not, you have just taken your first step toward understanding what MIDI is all about. Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language.
Yeah, maybe let's pull up the match EQ a little bit more. And there's also this option for fading extremes. So you can do things like this. So the top end and bottom end are faded a bit. And these are really the ranges where you're going to have to do the most touch up with a separate channel EQ later. The mid-range, it tends to match the mid and high range pretty well. It's generally like a bass and air or treble issue. So I may find myself coming back in here and boosting the bass or cutting the bass a little bit to match these. So let's see what that sounds like now.
Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard,
so it's getting pretty close. At this point, I think it's really just more of a volume issue than anything. This one's just a bit louder.
Look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language, and a list. Look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language, and a list of specifications.
So there's still a bit of a difference, but we're way more in the ballpark now. And all I did there is I just pulled down the gain just right on the channel by about 2 dB, because this one was coming through just a bit more, a bit louder. But overall, I think the tone is pretty well matched. Now, the thing is, with the channel EQ here, the goal isn't to like make your voice sound like radio voice. The goal is to match the two sources together first, then add whatever plugins or enhancements you want to add. So when I have a situation like this where I need to match, two mics, the tone of two mics, after I do the matching, I'll select both of the tracks. I'll create a summing stack. Okay, so again, I get my two tracks in here that have been matched. Now I can add whatever effects I want to the track stack to process both of these the same way, rather than having to create two separate channel strip settings to try to manually match these just by messing around with two different EQs. I really like using the LA2 to kind of just round out the dynamics a bit.
Let us now look at how it all started and what the basic principles are behind MIDI. MIDI is a standard, a protocol, a language, and a list of specifications.
Yeah, so I probably need some de-essing. I need maybe some more tone shaping with another EQ, but now the source audio is essentially the same. It's not exactly the same, but I'd say it's, maybe 90% in the ballpark. And that's really what you're going for here. You're not going to get perfection, especially if the two microphones are like very different, like trying to match a full-size mic to a lapel mic, for example, or matching a lapel mic to a boom mic. So in situations like that, it's a matter of getting a little bit closer to the reference, but you're never really going to get all the way there. So there you go, guys. That's how you can use the Match EQ in Logic Pro to match dialogue, narration, and voiceover tracks in Logic Pro. I hope you guys enjoyed this video. If you did, please leave it a thumbs up and subscribe to the channel to see more content like this. As always, thank you so much for the support, and thanks for watching.